In this video, we're going to go over the mean and variance for the binomial distribution. Now suppose that x is a random variable having a binomial distribution b, n, p. So the n, recall, is the number of times that some experiment is conducted, and p is the probability of success in one trial. Now x represents the number of successes observed when the experiment is conducted n times. Then we have the results down here. The mean for x, or the mean for the binomial experiment, is given by n times p. The variance is going to be n times p times q, and the standard deviation is the square root of the variance, or the square root of n times p times q. And remember here, q is the probability of failure, which is 1 minus p. Now, as we'll see when we look at the examples down here, it's fairly easy to understand why the mean is n times p. But the variance and standard deviation, they're a little bit more difficult to understand intuitively. We could prove them mathematically why these equations hold, but that's beyond the scope of the course. So let's take a look at this example. So for this problem, we flip a coin 10 times, and we let x be the number of heads that appear. So this is going to be a binomial experiment, and we want to calculate the mean, or average outcome, for x, and then we want to find the standard deviation. Now let's think about this intuitively before we apply the equation up here. If you flip a coin 10 times, on average, how many heads do you think should appear in the 10 flips? Well, obviously the answer should be 5, right? If you have a fair coin, the probability of getting heads is 0.5, and so we should see out of 10 flips, on average, 5 heads appearing. Well, notice if we apply this formula here, that's exactly what we get. So for this experiment, the n is 10, and considering success to be heads, the probability of getting heads in one trial is 0.5. And so notice that when we evaluate n times p, we get 10 times 1/2, which is exactly 5, as we would expect. Now the standard deviation is going to be the square root of n times p times q. In this case, q is 1 minus p, it's also 0.5. And so the standard deviation is going to be the square root of 10, that's n, times 0.5, that's p, times 0.5, which is q. And so we get the square root of 10 over 4, which is approximately 1.58. So that would be the standard deviation for x, where x is the number of heads that appear when you flip a coin 10 times. Let's take a look at another example. So this is a problem that we had done previously. So recall that for this problem we have 5 flights daily from Pittsburgh via U.S. Airways into the Bradford Regional Airport. And suppose that the probability that any flight arrives late is 0.2. So 20% chance that a flight will arrive late. What is the mean, or average, number of late flights per day? And what is the variance and standard deviation of the number of late flights per day? Alright, so for this problem, the random variable x is the number of late flights in a day. The number of flights, n, is 5. That's given in the problem up here. And if we consider the observation of a late flight to be a success, then the probability of success, which is observing a late flight coming in, is 0.2. That's given to us in the problem. And the probability of failure is actually a flight that arrives on time, in this case, is 1 minus p, or 0.8. So now we just have to apply the formulas. So the mean number of late flights in a day is going to be n times p, or 5 times 0.2, which is 1. So on average, you can expect to see 1 late flight per day. The variance is going to be n times p times q, so 5 times 0.2 times 0.8, that comes out to be 0.8. And the standard deviation is just the square root of the variance, so that's going to be the square root of 5 times 0.2 times 0.8, or the square root of 0.8, which is 0.89. And there you go. So that's the mean, variance, and standard deviation for the number of late flights in a day. And that concludes this video on calculating the mean, variance, and standard deviation for the binomial distribution.